All right, today's lesson is 12.1, the Pythagorean Theorem, and this is a formula you're going to be using now to find missing sides of a right triangle and then to prove whether or not a triangle is a right triangle. All right, so there's two parts to it. So first of all, it's understanding the formula, which is right here. And what that says is when you have two legs of a right triangle, which make up the L shape there, you can square them, all right, and then add them together, and then the hypotenuse will equal that sum, but then you have to take the square root of it, all right, because a squared plus b squared equals c squared. All right, so that makes sense in a second here. So let's take a look here. This is how you would go backwards now to find c. C is the square root of a squared plus b squared, and that is how you find this side right here. So here's some examples. All right, so take a look. This is the most basic one, I would say. All right, so we have a is 3, b is 4. All right, so let's use our formula here. So I'm now going to do 3 squared plus b squared, which is 4 squared. All right, and that's now going to equal c squared. I don't know what c is yet, of course, because I have to use algebra now, all right, to find that out. But now I have 9 plus 16, my two squares equal 25. All right, so this is how it's set up. So c squared equals 25. And now in order to get rid of my square, I need to then take the square root of both sides. All right, and once I do that, c will equal 5. All right, so that's, again, how you would solve for c isolated there is you sum them and then you take the square root to get there. So that's how you use the formula. Let's look at another example here. All right, so we have our a and our b, and we're trying to find our c. All right, so this is how you would set it up. 24 squared plus 7 squared equals now my c. All right, and then I'm going to have to take the square root of that. All right, so one thing you might want to do is take a look here. If you're using a Google product, all right, you would then type into your search scientific calculator, and what it does is it gives you this nice little one up here that you can keep on your toolbar, and you'll see here that this has the square button right there, and this has this, the square root button right there. So that's really going to help you for today's lesson. So good to have that, for future. For future use. Now let's look at this again. I'm going to open up that calculator. All right, so once that's up, I'm going to do 24 squared. All right, so that's 576 plus 7 squared is 49. Now I'm going to hit equal. All right, so this is going to be 625. I can't do both at the same time, so I just want to show you. So now I'm going to take the square root of that, and you'll see the answer is 25. All right, so now I go back here. This is what the calculator said, right? Adding those two together. And so now I need to take the square root of that. And again, that's where your calculator comes into handy because you don't want to guess what times what equals this number, right? So that would be 25. Your missing side is 25. So pay attention to which side is missing in your work. Is it C? If it's this one right here, you're going to add those two together. If you're missing one of the sides right here, you're going to have to then subtract it from your total, which let's look at one example of those, all right, which would be this one right here. All right, so let's take a look right here. So now my missing side is, if you want to call this A and the other one B, my hypotenuse is always the one across from the right angle. So this is always going to be C, and this should always be my highest length. All right, so I would set this up again like this, A squared plus b squared, which is 12 squared, equals c squared, which is 15 squared. All right, so once you do that, okay, so you can hopefully do that one in your head. 12 times 12 is 144. I think some of you guys can do 15 squared in your head. If you can't, use your calculator. 15 squared, you have 225. All right, and now I need to know what a squared is. All right, so what I do now is I subtract 144 from both sides so I can get a by itself. So let's do that. I'm just going to keep just using computation here so I don't have to go back and forth. All right, and you guys will see now how this comes nice and tidy. This equals 81. All right, so a squared equals 81. And now in order to get my length, I need to take the square root of 81. What times what equals 81? And that is 9. All right, so you can always check your work when it comes to this. All right, I'll just show you that in a calculator one more time. If you take 9 squared plus 12 squared, it should equal 15 squared. All right, so one more check. 9 squared plus 12 squared equals 225. I'm going to take the square root of that. 15, it matches. That means I have it correct. So that's how you calculate to find the missing side. And the other part of this lesson now is going to be testing to see if a triangle truly is a right triangle. All right, so you're going to be given sides right now, and you're going to plug them into the theorem to see if it's actually equal. If they are, then it's a right triangle. If they're not, then it means it's not a right triangle. All right, so let's take a look at this one right here. Tell whether each triangle with the given side lengths is a right triangle. All right, so take a look. Is it set up with my C as my highest? It is. All right, so now if this is a right triangle, when I use these parts, this will be equal. Okay, and if it's not a right triangle, this will not be equal. So this is how I use my calculator. All right, so 9 squared, you could have done that in your head, right? 81 plus 40 squared equals 1681. So now if this is a right triangle, all right, I'm going to hit the square root and it's going to equal 41. All right, and it does. All right, so that means that this is a right triangle, all right, because the three sides, when I plug them in, they equal the sum of the Pythagorean theorem. All right, let's look at another example. All right, so right here, let's use, let me clear this out, sorry. I don't know why it's not clearing that. All right, there we go. All right, so here we go. A squared, 8 squared plus b squared equals c squared. So this one's good because it uses numbers that are more friendly, so you don't have to worry about that calculator. All right, for now, to help understand it. So right here we have 64 plus 100. All right, so right off the bat, you should know what the square root or the square of 12 is. 12 times 12, right, is 144. And so you'll see right now, all right, there's your sign. 100 plus 64, 144, or 164 does not equal 144. So this is not a right triangle. All right, so that's what you're doing. You're proving using your formula. All right, so square them, add them, and then take the square root, and it must equal the third number, the c. Okay, so that's what you're doing there for both. All right, so please complete in the boxes there for those of you guys that are typing them in. The keyboard function is going to be this key right here. All right, so that means that shows square. You can't put a raised to, so this is how you would do that to show your work. You would do 5 squared plus 4 squared equals c squared. All right, you can put a little 2 next to it. It doesn't, it doesn't raise it up, and so that's the symbol you guys are going to be using in high school. And so technically you didn't have to do that, but those of you guys that are going a little bit deeper with the work, so this is what you would do. 25 plus 16. And we had questions on this one during class, and it was a little strange, right, because we have 41. And so if you can take the square root of 41, which is going to be a decimal because it's not a perfect square, all right, so here we go. It's going to be 6.4. But what I can do for that is I can just put this. All right, you can put the root of 41, or sometimes in high school they want you to type square root 41. So that's how you would show that. And then on the last examples here, you're going to prove it based off of our formula here. All right, so you would take 15 squared equals a plus b squared, a squared plus b squared, and see if it equals. All right, so those are the problems that you're doing. And then we're just practicing using our formulas there. So any questions, let me know, and download this extension app for future, because it's a really, really nice one. Again, that's a scientific calculator.